Over the last couple of years, the techniques and tools used for persisting and querying data have grown at an incredible pace. While it's still safe to say that a relational database are not going anywhere, we can also say that the ecosystem around data is never going to be the same. Of all the new tools and solutions, for me personally, Redis has been the most exciting. Uh, why? First of all, because it's unbelievably easy to learn. Ours is the right unit to use when we're talking about the length of time it took me to get comfortable with Redis. And second, it's extremely fast. The name Redis means remote dictionary server. The Redis project began when Salvatore Sanfilippo, he was the original developer of Redis, he was trying to improve the scalability of his Italian startup, developing a web log analyzer, and after encountering significant problem in scaling some types of workloads using a traditional database system, Sanfilippo began to prototype a first proof of concept version of Redis in TCL. Later, Sanfilippo translated the prototype to the C language and implemented the first data type, the list. After a few weeks of using the project internally with success, Sanfilippo decided to open source it, announcing the project on Hacker News. The project began to get traction more so among the Ruby community, with the GitHub and Instagram being among the first companies that adopted. So what is Redis? Redis is an open source in-memory data structure store which supports doing strings, hashes, lists, sets, sorted sets, bitmaps, hyperlog logs, and geospatial indexes. Needless to say that it's rich in support of doing all kinds of data and also has a high availability replication and automatic partitioning, to name just a few things it does. So if you ever wondered if Redis was a good option for data persistence, it is. Redis offers also all kinds of data operations that you can run on the types mentioned above, and we'll go through them as we explore the data sets later. Uh, Redis was written in NCC, which makes it friendly with the Unix-based systems like Mac or Linux without any other dependencies. Redis doesn't officially support Windows, but there are options available. You usually wouldn't run this in production, but there are no limitation while doing development. So let's move on why to use Redis. Here are the biggest benefits of Redis: performance, flexibility, durability, language support, and scaling. Main performance of Redis is speed. It's blazingly fast. But how exactly? Let's go to the official website. Okay, here you click on documentation, and here you will find a link to the benchmarks. So here you will find all the stats for performance and speed of Redis. And we can clearly see that performance of Redis can go up to 130,000 requests per second and even more. So it is super fast. Um, Redis is extremely easy to use. Um, um, Redis is no SQL data store. There is no need for defining any structure like tables, rows, and columns, and there is no need for any statements like insert, select, update, or delete. Read and write in Redis are pretty simple and straightforward. Although it locks data in memory, in cache, it has an option to write on the disk, and this option is configurable. Most people use it as a cache or a second database. So if you've got a database, or your server is saving your data on disk, but you're having problems scaling that, you can use Redis normally to cache, but also to keep the data from the database in memory so you can query it. Some folks do actually use it as a first class database. In other words, they do not have any other database. This is their only database. So Redis supports a wide range of programming languages. The commands to the Redis server should be the same and simply some syntax changes based off the client that you're using. So let's review the option. Let's go to Redis IO and then click on client section. And then you will see, if you take a look at all of the languages that are covered or have implementation of Redis, you will see that it's well covered. So if you want to work with a C Sharp, if you want to work with a C++, Ruby, Swift, or any other languages listed here, all you have to do is basically click on the language, and then you will see what are the libraries that you can use. So for example, you have eRedis, HiRedis VIP. The ones that are listed marked with a star, that's the one that Redis recommend to use. So, and at this point, all you have to do is just to click on a link and then go to the library and use the instruction that I mentioned right here. So as you can see, there are many options to get started with Redis. Okay, let's close this. Right. So how do Redis scale? Redis have very good master-slave replication feature. In Redis, you can use different instances of Redis, and we can make anyone as a master and other as a slave. And one of the very efficient use can be master can be used as a write-only data store, whereas one of the slaves can be used for read-only, and other can be used to write data to the disk. This can increase the performance while master and one of the slaves are doing write and read, and the other one is writing data to the disk at the same time. So who uses Redis? Here are some companies that use Redis. Let's go to official website to see more. So here you can go ahead and open popular sites that use Redis. And it's a bunch of them. Okay, so we can see that Redis is very popular. Let's close that. Okay, so what are the data types that are available? We will implement all of these data types later in our application client. So right now we'll just quickly go over them. Redis is not a plain key value store. It's actually a data structure server supporting different kinds of values. What this means is that while in traditional key value stores, you associate string keys to string values, in Redis, the value is not limited to a simple string, but can also hold more complex data structure. So the following is the list of all the data structures supported by Redis. Redis string is a sequence of bytes. Strings in Redis are binary safe, which means that they have a known length not determined by any special terminating characters. Thus, you can store anything to up to 512 megabytes in one string. The next one is bit arrays or simply bitmaps. It is possible using a special commands to handle string values like an array of bits. You can set and clear individual bits, count all of the bits set to 1, find the first set or unset bit, and so forth. Bit fields offer an efficient, compact way to implement multiple counters in a single array, which allows incrementing and decrementing counters at the given position and flags overflow when the counter reaches its upper limit. Hashes, which are maps composed of fields associated with values, both the field and the value are strings. This is very similar to Ruby or Python hashes. Lists. which are a collection of string elements sorted according to the order of insertion. They are basically a linked list. Sets, which simply a collection of unique and sorted string elements. And sorted sets are similar to sets, but where every string element is associated to a floating number value called score, the elements are usually always taken sorted by their score. So unlike sets, it is possible to retrieve a range of elements. For example, you may ask, give me the top 10 or the bottom 10. Uh, just spatial indexes provide an extremely efficient and simple way to manage and use geospatial data in Redis. You can add unique items with latitude and longitude, compute the distance between them, and find numbers within a given radius range from a location. Hyperlog logs. This is a probabilistic data structure which is used in order to estimate the cardinality of the set. Don't be scared, it's simpler than it seems, and I'll show you later. Redis streams is an incredibly powerful data structure for managing high velocity data streams like a message queue. With out of the box partitioning, replication, and persistence, it can capture and process millions of data points per second at a sub millisecond latency. Redis Streams is based on an efficient Redis tree implementation, which makes the range and lookup queries extremely fast. It connects producers and consumers with asynchronous calls and supports consumer groups. It's important to go over the basics of how Redis saves the data and what persistence options comes with Redis. So with Redis, you have two persistence options available, which is journaling or append-only file and snapshotting, Redis database file. I'll go over both and explain their best use cases. All operations in Redis are done in memory, right out of the box. As an option, you can turn on an option called append only file, which logs every operation in the system file. So when the Redis server is restarted, it rebuilds a database of this file. This file can get very big and very quickly, but Redis is smart enough that if it gets too big, it will start over using the latest version of the dataset, shrinking the file back down to a manageable size. The next one is snapshotting, Redis database file. And it is similar to snapshot operation. It creates point-in-time copies of your data that you can retrieve in case of a disaster. It's as simple as that. When conditions are met, for example, a certain number of new items in data or a time base, Redis makes a snapshot of the data and writes it into an RDB file, which you can retrieve whenever needed. This is a default settings when you first install Redis, but you can always change them.
Okay, so let's move to the installation part. As I mentioned earlier, there is no official version of Redis for Windows users, but here's the link to the website where you can download the most up-to-date version, which should be at the top of the list. You will need to extract the zip file and based on your architecture, open either the 64-bit or 32-bit folder. I will leave this link below the video so you can play with it later. For Unix and Mac users, building it from the source is your best option. Okay, so let's go ahead and install it on our system. So go to Redis IO and then go into download section here and scroll all the way to the bottom to the installation part. Okay, so if you have the Apple Developer Tools installed, you can do the wget with no problem. If you don't, and in my case I don't, so I will do the curl instead. So copy this line right here. If you have Apple Developer Tools, you can copy the whole line. And let's jump to our terminal. Let's make it a little bit bigger so you can see. Okay, so we do curl slash capital O and we paste our link. Okay, and then it will download the files that we need. Then we need to extract those files. So we do a tar xcf and then we type in our file. So whatever version you're installing, you can just type the version here with no problem. Just make sure you're consistent in all the commands and you type in this version in each command. Okay, and then click enter. So now we have to open that directory, and let's copy this right here, and we need to navigate to that folder and do the make command. So let's do the make command. Quick note for those that don't have the Apple developer tools, when you enter make and you click enter, it's going to ask you to install those tools. So when you're done installing those tools, come back and do the make command again, because if you don't do the make command after you have the Apple developer tools installed, it's not going to work. So make sure you do that. So I just did the make command and I have the Apple developer tools installed, and it's going to do a whole bunch of stuff. If you do not see this, it means that you don't have the developer tools installed. It's going to ask you to install them and then do the make command again. If you don't, up until you see those things happening, it means that it has not been installed yet. Okay, so after it's installed, finished installing, we'll try to connect to our Redis server. All right, here we go. So what is the best way to connect to our server? Is to do source Redis server, and here we are. So this started our server, and if you see this image, our Redis server is actually installed. Now let's start the client. Let's go ahead and tap a second window for our terminal. So for Mac, you can do Command T to open the second tab. Okay, so if we do an ls right now, we will check in which directory we are. We need to be in the same directory, and we are in the same directory. So make sure that you cd to the actual directory where Redis is installed. Okay, so to open the actual client is source, and then it's Redis client as opposed to Redis server. So source Redis client, hit enter. So now we are connected to Redis server. This is the official IP address, and here's the port. So now we have an official client installed and a Redis server installed. So now that we've got a Redis server installed and running, and we could literally continue without installing any other tools. All right, so let's go ahead and move to exploration of the data sets and how to work with them. Strings serve as the basis of the Redis data sets, and we will explore how to work with them. For example, we will use the set command, and as you can see, whenever we start doing a command, it gives you some indication of what you can enter in there. So for example, for set, we can enter a key. So let's set the first name. Okay, and then we can get a key. Let's get first name, and it shows us our name. So this is how simple it is, and this is how you set a key and get a key. There is other ways to work with strings. Let me show you a couple. So let's set an address. For example, 123. Okay, and you can actually increment that address by doing a command that's called inc for increment, and then the key. And then it will increment that key by 1 automatically, and you can do that over and over and over. So let's do incr address, and it incremented it by one. So now it's 124. Okay, you can also use another command. And by the way, if you're looking for all of those commands, you can look into the Redis website. There is a cheat sheet that you can find, and you can filter it and see, filter it by the data sets, and look whatever you need. Okay, so there is another command here, increment by, where you basically can put the number which you want to increment it by. Okay, and it did it. The same, there is another command that works pretty much the same. It's decrement, and you can do decrement by 1, or you can do decrement by whatever number you want. Okay, so this is a good way to work with numbers. There is another thing that you can do. Let's say, for example, you want to do, let's set the country, United Kingdom. I cannot type today. And boom, we see an error. Okay, if you why is this error happening? Because it doesn't accept the composed name. It needs to be inside of double quotes in order to work. So whenever you want to enter composed names, sentences, and long composed name, anything that is not a single string, you have to use double quotes. So let's set a city. Okay. All right. Another command that is really useful, does something exist, and it's pretty simple. Let's do exist address. And if something exists, it will return an integer 1, which means it's true. If I delete the address and do the say command, it's going to show me 0, which means that the key doesn't exist. So one other command that I really like, sometimes you need to have a specific type of data that expires after a certain time, a password, or some pictures or whatever you want to do in your database that doesn't need to be there for a long time. So if you need that, you can do the command expire. Okay, let's set our zip code. Let's do this and try to expire that zip code. Let's do 10 seconds. Okay, so after 10 seconds, if I run this get zip command, it should not exist, and it's null. Okay, so you can also set this command in one line together with the expiration. So let's do set zip 37219 and expire. Let's put 15 seconds, and let's actually run the command so you can see that we do have that in the system. Okay, it shows that. But whenever I run it again, hold on, too early. Okay, now it's null. Alright, so let's move to hashes. Hashes are fairly similar to objects, such as those used in JavaScript. You set an object with a name, and then you can add as many field value pairs as you want. Let me demonstrate. So you create a new hash by doing hmset, and let's set a user to 3. Do first name Daisy, last name Meadows. Let's do street, church, city, Nashville. Click enter. So now we need to get the key. To get a key, we'll do h get all user 1, 2, 3, and now we can see first name Daisy, Cruz, Church, and Nashville. Okay, so also we can do what if we want to do just one key. If we want to do that, we can do h get user 1, 2, 3 city. Okay, so she lives in Nashville. Next command is hmget, and this allows you to actually get multiple fields. So for example, let's do hmget user 1, 2, 3. Let's do her first name and last name. Okay, and we have this. Alright, so you can also check if the data exists, and it's the same command as we used with list, exist, but you just add h. So h exist user 1, 2, 3, and let's check if she has the first name, and she doesn't because I entered the wrong user number. Okay, now we hit enter, and we can see that she does have that key. Okay, so we can also do the same thing we did with the list. We can increment or decrement the number. Let's set the address. Set user 1, 2, 3, and let's do address 3, 4, 5. And now we just want to make sure that we have that user 1, 2, 3. So now we can see that we have the address 345. Now we can work with that and play with that and do the increment by. So let's do h increment by the user 1, 2, 3 and address, and let's increment it by 100. Okay, and let's run that same command. Why it didn't work? Hold on. Increment by user 1, 2, 3 because I didn't type it correctly. Okay, so let's do this. Okay, and this. Now it should work. Alright, we can see that it incremented by 100. So as you can see, all the commands that we've used in the past in the keys are also working in the hashes. It's the same kind of data, it's just organized differently into a hash. So we briefly went over some basic commands, and unfortunately this video cannot be long enough, even though I thought it's going to be too much to talk about for 30 minutes, but it's short to show you all the data types and their commands. So I just wanted to show you the cheat sheet that I was referring to. So you type Redis IO and you go to commands, And this is where you have all the commands and their explanation. If you want to learn a little bit more about it, you can just click on it, and it's going to show you a little bit more. Like, just click on append only, and then you get to this page where it can show you what this command does and how you can use it. Okay, so the other thing is, because this can get pretty long and pretty exhaustive, you may be scrolling for a little bit before you can find something. You can actually go ahead here to the top and filter by the type or data type, and see what commands can be used with for that specific data type. Let's use that sorted sets, and here are some commands that you can use for the sorted sets. So go ahead to the website, explore the documentation, explore all the commands, and go play with Redis. You're gonna love it. It's really simple and easy to learn. And thank you so much for your attention.